Happy New Year! Are you having a good New Year already? Did you make any resolutions? I know I did. Well, at least Real Good AI has, and I'm excited to share some of those with you. Now, let's talk about three resolutions or goals or whatever you want to call them for this upcoming year. I'm so excited. The first one is I'd love to see the rating system out in the wild everywhere. Now, if you don't know what the Real Good AI rating system is, go check it out. In this video, I describe it. We're going to launch it early next year, and I would love to see this just on pieces of media on the internet, on websites, everywhere. In education, I am so excited. I think it will be so useful for us to have these nuanced conversations about how much AI is actually used in the content that people have created. So that's my first resolution. My second resolution is I'd really like to make a contribution to science. Now, that's really vague, but I think we have a couple pathways that I'm really excited about that are open right now. The first, I talked to you a couple weeks ago about the seabed data. Again, check this video out if you haven't seen that. But the general idea is that we're going to help contribute to the human knowledge of science of what's going on in our universe with AI. And I would love to see that make an actual difference to scientists. Another pathway we have going on right now is putting Gaussian process models where they don't belong. And I love it. They're my favorite models, and it's working out so well. This idea where we could generate things and have exact attribution to where every single pixel came from and what it's borrowing from. Revolutionary idea, and I'd love to see that totally come to fruition. My third resolution has to do with you all here. Thank you so much for watching our videos. We've been putting a lot of effort into the content here because we think it's really an important aspect of the Real Good AI mission to go out and talk about AI and talk about everything that we're doing, so that people can understand that AI is not all good or not all bad, that there is in between, and we need people to be educated on how to interact with it and how to talk about it. I'd love to see us reach 10,000 followers on every platform. Now, that's a huge goal, but I think we can do it. So share our videos, like our videos. We appreciate all the engagement, and thank you so much. Hope you're having a good new year. Drop what your resolutions are in the chat, and happy new year. Hello, Dr. Mandy Myskins here from Real Good AI, and I think I'll talk to you today maybe a negative. Like, let's talk about why Gaussian process models aren't already adopted. It's not that neural network people are like, no, I like the black box. Go away, anyone trying to fix it. No, there are actually some major scientific challenges that are roadblocks, honestly. And if you're not sure that they will break through, I can see why you would never go down the path of Gaussian process models. So let's talk about it. The first issue is computational infeasibility. And now, when I'm saying this, I don't mean like, let's just put it on a supercomputer for more time. We just need more energy to make this work. The usual issue with Gaussian process models has historically been memory, meaning that I actually can't store the thing I need to compute to do it, which no amount of supercomputer in the way that they're built now really will help that problem. It's not a time issue, it's a memory issue. And so I've spent maybe the last 6, 7 years. Oh, that's not even right, because I got to include my PhD. I spent maybe the past 10 years working on that problem, where now we can take a lot of observations in with Gaussian process models. And I feel relatively satisfied with the solution we came to, and the solution is called MyGPs, MUYGPS. If you want to look more into it, we have a few papers on it. But the important part here is that we break this apart so it's no longer this big memory issue. We need to solve a bunch of small problems instead of a big problem. And the computational efficiency and the memory efficiency is huge here. I mean, huge. Something that you couldn't do before, and now you can do in seconds. Like, it's crazy. So I'm really happy with that solution, and I think that it's not well known yet. I think it's relatively still under wraps. And whenever people try and fit Gaussian process models, I still hear, oh, but I can't do this. And it's because they're doing something really silly. So I guess misunderstanding about the models would be number 2, in that, you have to have an expert to fit them. They're not neural networks. They're not black boxes where it will just do everything for you. You need to actually have some modeling knowledge to be able to fit them. And there are not enough of us who know about Gaussian process models for this to be everywhere yet. And I mean, all the secrets. And really, the funny part is the secrets aren't even well written down. They're like passed down from advisor to student. Like all the secret back of the book answers, they never write in a book, which is so silly. I'll tell you all those things, by the way. Anyway, so number 2 is maybe knowledge. And the third issue is sort of flexibility in these models. Now, by design, you have to make some assumptions about your model so that you can do something, right? Like that's how we get structure in the model. But Gaussian process models tend to assume things that are close, very correlated, things that are far away, not so correlated. Okay, but that might not always be true. Think about a wave here, right? So things may be far away in the wave, but close together in similarity. Like we're seeing the same thing repeating. Okay, so we want to be able to understand and learn those patterns, those inconsistencies, and things that can happen. And Gaussian process models are not flexible enough to do this in their inherent state. So we're going to keep working this next year. And I just thought I'd tell you that neural network people are not bad people at all. There are these major issues. I just truly believe that there are solutions to these problems, and we're going to be able to move forward with Gaussian process models where they don't belong. Do AIs learn like we do? No. And I'm Dr. Mandy Myskins from Real Good AI, and let's talk about that. Now, when you and I say something or we learn something, we can take that knowledge and put it in different contexts. We understand what the words mean, what the concepts mean. They relate to things in other domains. For example, if I'm talking about a cow, you might know what a cow looks like, what a cow smells like, even maybe what a cow feels like. An AI has no concept of a cow other than the words that typically surround the word cow. So, just to give you an example of how this works, if I say the cow jumped over you would know the next word should be moon. This is completely nonsensical, right? Because cows and moons, that I haven't seen any cow astronauts lately, prove me wrong. This is a concept that we all understand because we've heard it many times. Now, you might have not even stopped to think about it if that made sense or not. That's the way the AI is telling you facts. It's just that it's reminding you what it's seen before. So be careful when you're talking to an LLM because they might just say the words that make the most sense that don't always mean what you think they mean. I'm always so surprised when I talk to people and hear that they're using AI. I'm telling you, it's a secret. Now, of course, I don't mean that their content or anything that they've created, that they're just putting prompts into AI and copy pasting the responses or posting that directly. That's not what people generally tend to be doing. Some reasonable people are using AI to like edit scripts, to give ideas, to bounce off ideas, to brainstorm, to do some of these tasks that don't even actually make it into the final product in a meaningful way, but they're not telling anyone about it. And I think that that is totally wrong. We need to be citing our sources about how much AI is going into every bit of content that we're doing. And we need to have the language to talk about gradations of how much AI was used. For example, if an AI filter was put on top, that's one level of AI. But if the words coming out of my mouth were generated entirely by AI, you would want to know that too. And those things should not be equally weighted, nor if it's a deep pic of me talking about it, be the same. So, what we've created is this rating system that people can start to use that starts to talk about how much AI was used when that piece of content was created. This opens up that conversation so people can talk about the good ways that they've used AI in certain areas, or talk about, where it goes in their content. We hope that you will join us and start using this rating system in everything that you do. Rate your stuff. Did you know that Real Good AI streams? We do on Twitch, twitch.tv/realgoodai every Thursday. Now, every other Thursday, it's a team stream, which is usually led by our in-house streamer, which is Skirm, our board president, who is also my husband, but more importantly, the board president of Real Good AI. And so he'll be there. I'll be there a lot of the times, and some other members of the team will join. Additionally, every other week, we do really great interviews with artists, with nonprofits, with scientists, and we get to learn about something new, learn about a new person's career, but also we get to ask about the interaction of AI and that career. How is it helping? How is it hurting? We talk about it all. What you're doing with it, what you're not doing with it. We get to the bottom of it. All the while playing video games, something like Minecraft or Power Wash Simulator, something that'll keep you engaged but entertained. Hope you enjoy those streams and hope to see you there. So, Real Good AI streams on Thursdays.
Your toy robot gives me an idea. We can use AI to find a recipe.
Now, I'm so excited that Sesame Street is talking about AI because this is a topic we really need to get to kids early before it's too late. But this isn't it. This isn't it. And let's talk about why. I'm Dr. Mandy Meiskens, the executive director and PhD in AI research. So there are several mistakes I think that they make in this video that could have been corrected that would make it a lot better and more reachable for the kids. Now, first of all, my biggest complaint is that there's no guardrails presented when this new AI technology is presented to the children. Actually, the application they pick using it to help you brainstorm for cooking is kind of an innocuous one, right? So it's sort of harmless in that regard. It's not something that you need for to make big decisions. Although he does say that it could be used for big decisions, which is a little sketchy. But the point is that it helps them make a recipe for dinner. Maybe that's not so bad. And he's using it with the kids directly. So the parent is using it with the child. However, those things are not explicitly stated as guardrails. There's no implication that the AI could ever be wrong, only that we didn't give it the right information. And actually the only learning that comes in the video about the AI is how you should give the AI more information. Now, there is a limit to that, obviously. There's information that's extraneous, would just make the AI more confused, that a kid might not be able to sort through, but more harmfully, there's tons of information you don't actually want to be putting into these AI systems because once they're there forever, and a kid doesn't know that. There's no semblance of you could only use the AI when I'm with you, or that the AI could make mistakes and could make you make something really bad when you're cooking, or that the AI is actually using resources to do what it's asking when you're talking to it and asking it. There are all sorts of issues that could have been chosen to highlight, and they did not talk about those guardrails at all. And I think that that's a huge mistake because we really need to introduce kids to the good and the bad while they're getting exposed to the technology, or else they'll just latch onto it. And there, as we have seen in the news headlines, there's all sorts of issues of the AI becoming too friendly with humans, and especially with kids. It's very dangerous. So I had hoped that some of that warning might be in the video. Now, even if that warning wasn't there because they wanted to keep it positive, it just hit this video hit me really the wrong way because the technology was just wrong. They've used the AI more like Google, where you're doing like a search where they had the one search and it didn't do what they wanted, so they deleted it and redid the entire search. That's not really the way LLMs work at all. You can ask follow-up questions with LLMs. So instead of the recipe is too long. Let's rewrite the whole prompt and re-explain the whole situation. Instead, one could have just said, make it a fast recipe to actually show how LLMs and how humans respond. It just doesn't feel very realistic. Secondly, when they're it's like implied that the AI is telling them step by step as they're cooking what to do next, which is just not a thing that exists yet. Maybe that was me reading into it a little bit too much, but it would give you just a list of instructions. There's no doing it as you're doing it. That technology does not currently exist. So it feels like we should accurately represent the technology so that kids get an accurate picture of what it might look like to use these tools. Because this is not a future problem. AI is going to be in their toys, be in their tools, be forced on them at school. So they're going to need from home, from parents, from Sesame Streets and other nonprofits, how to best interact with it. Now, Sesame Street, if you'd like to take another shot, we here at Real Good AI have a team of scientists. We would love to consult with you and help you make good decisions in the videos that reach the people. So, thank you for listening. Sorry this was a long video. I really wanted to talk about this. I think we can all agree that AI on social media is a huge issue. One second you're just scrolling, watching people talk, and the next second you're watching Bigfoot catching a fish and talking to the camera. Now, in that case, at least we can tell that Bigfoot isn't real. Sorry, believers. But in other cases, it's not as obvious. And that's where the problem lies, is identifying what is AI and what isn't AI. And so we're trying to advocate for this system of rating AI in your videos. So the idea is that based on how much AI you used in your video, you would get a value between 0 and 5 that would be posted on your video. And additionally, you could maybe in the future, if we get YouTube and TikTok and all of them on board, we could filter so that you can only see levels of AI. So you know what you're seeing is at least self reported to be some level of AI. When people hear that our nonprofit is called Real Good AI, they assume everything we're doing comes from AI. And that couldn't be further from the truth. And I want to give you a few examples. I'm Dr. Mandy Meiskens from Real Good AI. I'm the executive director. And let's talk about some things that we tested and where AI has totally failed. So the funniest one is probably a task that you might think that AI could do. So we stream weekly. Out of those streams, one could hope that clips could be cut automatically using AI to know where the impactful moments were. There are all sorts of tools online that people will try and sell you for this exact thing. And it'll even tell you, it'll pull out clips and be like, I think this one is cool because of this. And it's all nonsense. So we tried this. We used some free tools, by the way. We would not spend nonprofit money on testing these tools. It would cut people in the middle of sentences, in the middle of thoughts, and then just give you pieces of what they were saying. And that was the whole clip. And, it wasn't even something interesting. It just generally did not do as promised at all. Now, I think this is really emblematic of how people would like AI to work, right? Like they'd like to automate tasks like pulling things out of things or, writing a newsletter for them so that they don't have to worry about it at their very small nonprofits. But those things are really harmful still right now in terms of the AI making your nonprofit mission very generic, not giving you the quality that you really deserve. So if it's not worth doing, don't do it. The technology is quite not there yet, and we're all human for now on socials. I have such exciting news. Dr. Mandy Meiskens from Real Good AI here. And this AI scale that I've been talking about a lot, it's a real thing now. Real being the key word. And we're calling it the real rating, as you can tell by our name, but also real is an acronym, meaning the reported engagement with AI level. And so we're so excited. We're officially launching this program. You can go, you can use the emblems we have on our website. You can access these self reported labelings. Please put them on your appropriately on your media or anything else you generate. Please share this rating system with other people. We'd love to hear your feedback of how it's working, what more guidelines you need. We're working on more guidelines in a questionnaire right now to help people rate. If you have questions about what level yours should be, I just want to remind people it's not necessarily bad if you have to rate your AI a little bit higher. We just want to talk about where AI is being used. And so we're excited to share it with you. It's obviously on all of our media that we're going to be producing now. And I am so excited that this program is finally becoming a real thing. Real. Yay. Good
Good news!
news! For this first month of the year, we don't just have one coloring page that we're releasing, but we actually have 5. That's right, STEAM, which, if you don't know, stands for STEAM, or Science, Technology, Engineering, Arts, and Mathematics. Now, we have a page for each of these, so you're going to learn a little bit more about them. And each page also has its own little cute animal mascot, so I hope you or your kids enjoy that. So thankful to be able to do 5 pages in 1 month. That's only due to your generosity and the fact people are supporting real good AI. So thank you for helping our impact become bigger, and thank you so much. Enjoy the 5 pages. Are you tired of your Google searches turning into AI? That's maybe not even right. I just learned that if you put dash AI after whatever you're searching, it doesn't do the Gemini summary. Sometimes you just don't want the AI. You need the truth. Go try it. Dr. Mandy Meiskens here from Real Good AI, and this week on our interview series, we're going to be interviewing Dr. Brant Belson. Now, you might not know his name yet, but I think there's a good chance you've seen some of his machine learning AI stuff, or at least heard about it. So he has a PhD from Princeton, but he's worked for so many interesting startups in the Bay Area. I think he's going to have a lot to say, and we're going to learn a lot from him. So hope you enjoy and see you there. You might be doing all your fancy modeling absolutely correctly, but still getting the wrong answer because you're making a silly mistake. I'm Dr. Mandy Meiskens, and let's talk about normalization. Now, what do I mean by normalization? When you get data, it's going to be in different units. There are some models where that changing doesn't mean a thing. Like you could throw it in whatever normalization, like linear regression, like it's going to do that sort of normalization for you just in how it works. But there are certain models, certain cool models like Gaussian process models, jarring coming. It's really important that the interpretation of changing one in whatever units you have it in means changing some percent. So like in Gaussian process models, everything is based on how far away things are. If the units are different, they mean completely different things. So what do? There's like a bajillion different ways you can normalize your data. I did this one project where I was looking at pictures of stars and galaxies, and the background noise of the image made a huge impact. So you had to like zero out that baseline and then normalize. There are multi steps to this. You always need to think about how you're going to put the data in the same units before you start fitting your models. Have you heard about this Clair Obscur Game Awards AI controversy? I'm Dr. Mandy Meiskens, and let's talk about it. Now, you can go ahead and read more details if you're interested, but basically, what this controversy brings up is AI in video games and how it should be used and how it shouldn't be used. Quick recap, there was some AI generated content that was meant to be a placeholder that made it into the final product of this game, and after winning awards, the awards were then rescinded because the Game Awards had said that they did not want AI in the product at all. Now this company was saying everyone uses AI, they're just not talking about it. Now I'm really glad that we have the real rating because we have the vocabulary to talk about the differences in impact based on your 0 to 5 rating. Now, particularly once content actually is making it into the final product that is AI generated, that's at least a 3 on our scale. And possibly higher, depended on how much AI there is or how important that AI is to the final product. And I do think it is a little unfair for the Game Awards to say no AI, period, because any AI used in business practices, otherwise as part of that development, even if it doesn't make it in or isn't even related to the art at all, if it's related to writing emails, that should be cited, and that is using AI. So I'm glad that we can talk and have these conversations now, and so hopefully in the future, they'll adopt our rating system and say no threes, only twos or lower. Oh, what do you think on this controversy? What do you think on our rating scale? Do you remember when Mark said,
From what I understand, the current way that language models and like machine learning models work today is based on linear regression, right? I don't fully understand what that means, but it's based on linear regression. Gaussian processes uses Gaussian distribution, which is like a random distribution type, to more efficiently find the lowest thingamabob for the thingamabob, right?
now we still love Mark, but that's not quite right at all. Actually, all of machine learning and really Gaussian process models included can be traced back to like foundational models that are based on similar stuff as linear regression. However, I wouldn't say that neural networks are based on linear regression and Gaussian process models aren't. I actually think that they are more similar the opposite way. So, Gaussian process models are actually just a one step more complicated model than linear regression itself. So, in linear regression, you have to make a full set of assumptions about how you're going to fit your model. Now, you assume that you're fitting a line, and you assume that there's some errors around that line. You're fitting data around it. It can't be exact, that would be impossible. And so, how those things are wrong off the line is where Gaussian process models differ from linear regression. So in linear regression, you assume that those errors that they're making totally random. Now in Gaussian process models, we don't assume that utopia of everything being incorrect. And we know that there could be correlation left over. So meaning that if things are close, they're more related than things that are far away. So for example, the temperature in two cities in Ohio is much more similar than the temperature in Ohio and California. Sorry, I had to make it higher because the California weather's better. Lived both places. Um, anyway, so the idea is that there is extra correlation built over in that model, and you're trying to understand that correlation. So, like how that works in variable space, and so it's a one step more complicated model than a linear regression model. In summary, I really think that Gaussian process models are more like linear regression, but really linear regression and these types of foundational models run all the way across machine learning. So if you're looking to get into and learn more about data science, really look at these foundational models and really dig deep into them because they will help you later on in fancy models like Gaussian process regression. Dr. Mandy Meiskens here from Real Good AI, and this week on our interview series, we have Dr. Katie Schmidt. She's one of my favorite people from the Lawrence Livermore National Laboratory, as Mark would say. But she actually was my mentor when I first started there as a postdoc, and she thus afterwards became one of my closest friends. She's such a great person, has had an interesting career. I think we'll get to learn a lot from her, but also she's going to tell us about a project that the Lawrence Livermore National Lab is leading, and Real Good AI is participating in. It's about uncertainty quantification and surrogate modeling, which generally means we're looking at how wrong machine learning models can get and how we can tell how wrong they might be. So it's a really interesting topic, and she's a really interesting person. So this is going to be one of the good ones. See you there. Did you color in STEAM yet? I'm Dr. Mandy Meiskins, and remember this month we have 5 new coloring pages up on the website. The artists did such a great job. They're all so amazingly talented, so please go check it out. Now, I'm a math person, so I had to take a whack at coloring the M axolotl in, which was so adorable, so much fun, and let me know if you can do better than this. Love to see your examples. These would look great in a classroom. They'd look great, hanging in a kid's room, any of that. So let me know if you use them, and go have fun. Hey, have you checked the Distractable merch store today? Well, if you love Distractable and you love Real Good AI, you definitely should. Now, the boys have a Share the Love drop of merch today that includes like these adorable Valentines. The artist did such a good job. Some stickers, some t-shirts, some sweatshirts. This is an old sweatshirt from Christmas. I know it's out of season, but I love it so much I wear it all the time. Go get yourself or someone you love a pink one for Valentine's Day. And a portion of the proceeds, the boys are planning on donating it back to Real Good AI in order to fight all the bad things that are happening in AI right now and try and fix it and fix AI for good. If you're interested, go check out their merch. It's adorable.